Hi guys, welcome back. So this is the 22nd video in this series that I'm creating, this playlist, demonstrating how to use RStudio to conduct data science and data analysis tasks. So the last two videos I demonstrate how to use the summary function and the describe function to obtain descriptive statistics for entire data sets or for individual variables. I'm going to make a similar video here where I will demonstrate how to obtain descriptive statistics, but we'll take a more basic approach and we'll just use some of the basic R statistical base functionality to do that. So what I'll do is in this video I'll just focus on how you can, for individual variables, how you can obtain measures of center and measures of spread. So how to obtain the mean for a variable, the median for a variable, the standard deviation as a measure of center, and the interquartile range. So the mean and the standard deviation being a measure of center and spread, the median and interquartile range likewise being a measure of center and spread, but more robust. So we're going to look at non-robust and robust measures and descriptive statistics. So what I'm going to do is, I've got this script already created. I'm going to import the tidyverse. I'm not really going to need it in this particular video unless I decide to plot something. I'm not likely to though. I'll try to keep the video as short as possible, and I'll just demonstrate some of these things. I'll also highlight some of the issues that can come up. So first of all, I'm going to import the MT cars data set. So that's I think it's the motoring time cars data set. It's a small data set with different variables recorded on different makes of cars from, I think, the 70s or something like that. And I've got this saved in the folder that I'm working on for this particular project, this data analysis project. I've got it saved as a CSV. So I'm going to use the read.csv function. I'm going to save it as a data frame, assign it the name df as a data frame. You can see that's worked, and I've now got in my environment here in this top right hand side, you can see I've got this variable df, 32 observations, 12 variables. And we could use the glimpse function, glimpse, and then pass the name of the data frame df. And you can see, as we've done this a number of times in previous videos, gives us the name of each variable, the data type, character, double, integer, double precision, that is, a lot of numerical categorical variables in this data set, so it's quite useful. And we're just going to be really looking at the double precision ones where we're calculating means, standard deviations and things like that. But that's what the data looks like. So all I'm going to do first of all is I'm going to calculate the mean for this MPG, miles per gallon variable. So we've got 32 observations for different vehicles and the miles per gallon, and we're going to basically look to see what the mean miles per gallon is for these different vehicles. Okay, and to do that, using the basic R syntax, you just type mean, the function is mean, and then you pass in the variable of interest in parentheses. So if I just start typing, you can see it's quite useful if I start typing this out, mean, open the parentheses, you can see that R gives me this prompt, tells me the arguments that I need to supply, essentially. So it recognizes it as a function straight away. I've already got it typed out on my script. So what I've typed mean, open my parentheses, and I want to look at the miles per gallon variable from the df data frame. And I've demonstrated how you select individual variables. You specify the data frame, and then from that data frame you tell it to select MPG using this $sign here. So if I run this line, what we will see in the output below, let me drag it up a bit, make it a bit bigger, you can see there it's run that command and it's returned a value of 20.09062. So quite precise to like 5 decimal places, but we've got a mean MPG of just over 20 miles per gallon for these vehicles included in this data set. So that's really simple, easy to do. But one thing to be aware of is how to deal with missing numbers. So if you've got variables and if you've got a huge data set, this isn't particularly big, we've only got 32 observations, 32 different vehicles. But if you had a big data set from some experiment where you've got data from hundreds of participants or hundreds of observations and cases, maybe thousands. You might have some missing data in there, and this will create problems. So to demonstrate this, what I'm going to do is I'm just going to create a variable, just a small variable, but I'm going to include a missing data point. So here I'm creating this variable x. I'm using the assignment operator, and then I'm basically using C for concatenate, and then within parentheses I'm passing the values for that particular variable. And they're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. Some negative, some decimals, mostly integers, some negative values, but the main thing of interest here is this NA, which tells us there's a missing value, so the last value is missing. If I run that, you can see now we've got this new vector of numbers, 11 numbers, and it's called x. Now we're going to encounter a problem here if we try to work out the mean value for this particular variable x. So if I run mean and I just pass x as the argument, you'll see below in the output window here, it returns a value of NA. So it just returns missing, essentially. And that's because R doesn't know how to coerce missing values. So it's kind of throwing up an error, essentially. It's not worked. It's not returned what we wanted. And that's because when we use this mean function, when we pass in the minimum information we need to pass as the variable, but there's this other parameter there, which is na.rm, which is remove missing values, and by default that's set to true. So in order for us to get the mean of this vector of numbers, what we need to do is tell R to calculate the mean but exclude any missing values. And the way we do that is quite simple. We call our mean function, the first argument we pass is our variable x, then a comma, and then we use na.rm, which means remove missing numbers, remove na values, and set that equal to true. So if I run that now, what you'll see is below in the output window, we get this in the console, we get a mean value for x of 8.22. Okay, so that's worked. Just as an illustration, I thought I'd just show you how you can. So all I've done so far is just obtain those values, but I've not saved them as objects or values within my environment, and we can do that. So one way we could do that is I'm creating a new object called result.mean. I'm using the assignment operator. I'm saying pass the mean of x to it. So if I run this line, remember, so it's saved there, it's saved result.mean, and it's saying na_real. So that's telling us that's kind of it's not what we're expecting, but I've made the same mistake as we made the first time up there. It's got a missing value, and I've not told R to remove those missing values. And where I've saved it as a separate variable, it's not automatically printed the result out to the console below. So to do that, we'd need to use a print statement. So I'm saying print result.mean, and if I run that, we get that same incorrect value that we didn't want, that NA value. So I'm just reiterating the point here essentially around missing values. But we can correct that, and we can save this as a separate variable, a separate object, by just including that na.rm equals true. So let me run both these lines now, and you see its result.mean has been overwritten with the correct value, 8.22, and it's also printed that result to our console below. So we've got it in our output window below. Okay, so that's the mean. So that's the mean. That's kind of simplest way to obtain the mean using base R statistical package, how to deal with missing values, and also how to save them as separate objects if you wanted them to, and give them a particular name. I've used result.mean, you could use anything you want essentially. So that's the mean. Let's look at the median now. So the median is a more robust measure of central tendency. If we're looking for a central tendency measure for our data, the mean can be skewed by extreme values. The median is not subject to that because it's just calculated using values within the the interquartile range essentially. Okay, so it's calculated using the ranked values. So extreme values are not going to influence the median. It's just going to be the middle value in the data set essentially, ordered from smallest to highest. Okay, so the median, very simple, again using base R statistical packages. So this time the function is median, which makes it nice and easy to remember, and we pass the variable that we want the median for. So here I've typed median, I've opened parentheses for the function, and then I've said I want the MPG variable from the df data frame, in that using that usual df $mpg syntax. And if I run that, we see in the output window the median is 19.2. So that's less than the mean. If we scroll back up a little bit for the MPG variable, the mean was just over 20 and the median is less than that. And we'd expect that to be the case because it is less subject to very high and very low values, extreme values in the data set. Okay, but if we have missing values, we encounter the same problem with the median. So if I just use median on that X data set that we created, that X vector of data, that variable, because it's got that missing value, we still get the same thing. We get this an output result of NA. Okay, so to overcome that, once again, we're doing the same thing. We've got to set our NA.rm equal to true. So we've got to change that default setting, specify specifically we want it to remove that missing data. And if we do that, we pass median X NA.rm equals true. What we now find is we've got a median value for that X variable we created of 11 values of 5.6. And that's different to the mean was 8.22. We'd expect that to be the case, that the mean and the median slightly differ. Okay, so those are our two measures of central tendency I'm going to focus on in this video. That's the mean and the median as a more robust measure. Let's look at some measures of spread now, or variability. Standard deviation is a really commonly used one. So we can calculate the standard deviation for an individual variable using the SD function. So we use SD and then in parentheses we pass the variable that we're interested in. So let's do that for the MPG variable. So SD and then df $mpg parentheses, and we see that the standard deviation for miles per gallon is 6.026948. If we look in our console below. Okay, so again, missing values, we encounter this same issue. If you try it and you've got missing data in your data set, if you just press that X variable that we created in, it returns a value of NA. So we need to do the same thing again and set that. We need to set that NA.rm parameter true, and it will remove the NAs and work out the standard deviation on the actual values in the data set that we do have. So if I run that, you can see what we get is a standard deviation for X of 19.2. Okay, so that's the standard deviation, nice and quick. I'm kind of speeding up here to try shorten this video a little bit. I'll keep it reasonably short. So our last measure of spread we'll look at is the interquartile range. The IQR, it is a robust measure of spread because it cuts off the top and the bottom 25% of data points, and useful, like the median is useful if you've got extreme values that might be skewing the distribution of your data. So the function to calculate the interquartile range for a variable is just IQR, and notice it is capitalized. So I've typed IQR and we're using capital letters. So IQR and then parentheses, I've specified that I want the interquartile range for the MPG variable. Let me run that and you can see the IQR is 7.375. Okay, so that's actually slightly more than the standard deviation for that variable. If we look at SD, the standard deviation was 6.026948. Same sort of thing. If we try to run the IQR on data with missing values, what we get this time, in fact, where I run IQR on X, is an actual error message. It's saying error in quantile.default as numeric, and it's saying missing values and NaN is not allowed if na.rm is false. So by default it's set to false. So to overcome that, to actually get the IQR for our X variable, we're going to again have to use na.rm, set that to true to exclude any missing values. So let me do that, and we see what we get is an interquartile range of 8.75. So as a measure of spread, much smaller than the standard deviation, but we expected that because it is a more robust measure and it's less subject to extreme values. Okay, so I hope this video was useful. It was just kind of how to individually obtain these types of descriptive statistics. I'm going to probably move on from descriptive statistics now, having made 3 videos about them, and we'll kind of move on and look at a few other things, and then probably get into some inferential statistical tests over the next few videos. Right, thanks for watching and listening. I hope this was useful and interesting, and I will speak to you soon.